This time we are going to use our area rules to calculate some areas of some very basic shapes, and then later on some more confusing shapes. So let's start out with a triangle here, and we've got this triangle here. We know that it is a right angle triangle, and we have a height of 4 centimeters and a base here of 10 centimeters. Nice and easy recalling that our area rule is equal to base times height over 2. That's for a triangle. So our base is 10 centimeters, our height is 4 centimeters, and we're dividing all of that by 2. So 10 times 4 is 40, divided by 2 is 20. Keeping in mind these are our units, and instead of just using our linear units, this time we are using squared units. So that's a really important part of this. You have to keep doing squared units. All right, our second question. I'm going to give you a nice easy rectangle. Keeping in mind all of those similar side lengths here. Let's go with 3.5 and 7, and they're going to be centimeters as well. So this time we know nice and simply our area, and we always write the rule first, is area equals length times width. I'm going to identify this long side as the length and this short side as the width. That's good communication justification right there. And I'm going to say 7 times 3.5. I'm going to get my calculator, and I'm going to type 7 times 3.5 in, and my answer is 24.5 squared centimeters. One more time. Now the trick to this is that sometimes we already know that you can do this sum. So we're going to start giving you trickier questions. For example, say I give you this rectangle. These are our side lengths. We've got this one is 8 meters, but this one we don't know. Now if I told you that the entire area was 36 square meters, we have to work backwards. We know if, I'll just straighten this page up for you. We know if area equals length times width, we actually have the area, so we've got this one. And we've also got this length measurement here. So we have this one, and what we're trying to find out is the width this time. So we do need to do some rearranging. Let's substitute first. Our area is 36, our length is 8, and we are multiplying by an unknown width. So we'll just keep it as W. You can change it to X if you wish. If we have something multiplying on this side, we want to get rid of it because we only want to find W on its own. We want to find this width. So we are going to get rid of the 8, and the only way to get rid of something that is being multiplied by it is by taking it to the other side of the equal sign and dividing it. So 36 divided by 8 this time equals W. If you get your calculator out and go 36 divided by 8, you will find that our width is 4.5. Now keep in mind, we're just trying to find a linear measurement, just a straight line. So this time our answer is going to be in the linear measurement of whatever units we're using here, so it will be 4.5 meters. So that's where it starts to get a bit trickier, when you have to start going backwards. You have to start working backwards from using the rule. All right, our next set of questions here, I'm just going to rule this off here. We're going to use some compound shapes. So, question number 4. I'm frozen. There we go. Question number 4. I'm going to give you a shape that looks like this. Knowing that this whole shape is 1, and we need to use, oops, sorry about that. So there's our shape. We've got one area we can find and another area we can find, and altogether the total area will equal the area in the first bit plus the second area there. That's our end point. We're going to try and work towards this part, but we need to do each of these separately. So we can see that, all right, here's a nice looking rectangle here, and I will give you some measurements. This one is 4, this one is 6. I'm going to say this is again 4. I've got that little dash there to indicate there that that's 4, And we're going to have to figure out some other measurements later on down the track. So let's work with A1 first. We can tell that A1 is a rectangle of 6 and 4. Silly me, I should say these are all centimetres. 6 and 4 centimetres. So area 1 will be length times width, remembering that is our rule for area of a rectangle. Our length is our long one, so our length is our 6 and our width is our 4, so 6 times 4. We know that that equals 24. We're working in centimetres, so it will be 24 squared centimetres. So that's our area 1. First done. Okay, but now we need to start thinking about our second part, and area 2 is not a rectangle. Area 2 is this shape here, and we've got this dash here and these dashes here. If we compare them up here to the rest of the measurements that we do know, let's have a look. We know that this one's 4 centimetres and this one is 6 centimetres. And it looks like we're using the same kind of dimensions, but we've got a very different shape here. So this is a triangle, so we need to recall the area of a triangle. Area of a triangle is base times height divided by 2. Now this time our base isn't necessarily touching the ground, because this is our base here, a nice flat surface with a line coming off it perpendicular, which makes this part our height. So our base is 6 and our height is 4. And we have to divide all of that by 2. So 6 times 4 is 24, which we actually found up there, divided by 2 gives us 12 squared centimetres. Alright, so we've got our two sections from our compound shape, our rectangle, our triangle, and now our final section will be to find our total. Now our total area, remember, was A1 plus A2. We have to add our first one, which was 24, and our second one, which was 12. So we would have to say 24 plus 12, which is equal to 36 square centimetres. So our compound shapes aren't doing anything different. What they're doing, they're using the same rules over and over, but you need to consider the shape as a whole.